Okay, we're almost home free. Here's the last installment of this lesson. So for number 5, the first thing I notice is there are 2 terms. And I see an x cubed. So I'm going to start thinking about cubes. So if you look, 24, that's not a perfect cube. There's nothing I can multiply times itself 3 times and get 24. But there is a GCF in those 2 terms. There is a common factor of 3. If I factor that out first, I have 8x cubed plus 27. Now what's left? 8x cubed is a perfect cube and 27 is a perfect cube. So remember, for cubes we need to identify a and b. So a, we need the cube root of 8x cubed. So I need to multiply 2 times itself 3 times to get 8, and x times itself 3 times to get x cubed. And then for b, I need to multiply 3 times itself 3 times to get 27. So remember, our cube formula is kind of long. It's a binomial times a trinomial. So we have a plus b. Then we're square a. So 2x times 2x is 4x squared. Opposite sign. Then we multiply a times b. 2x times 3 is 6x. And then a positive, and we square b. 3 times 3 is 9. So that is my factorization. Number 6, this isn't one that we're going to see a whole lot now, but this is an idea that is going to come up later in the course. So it's a good idea to start looking at it here. First, I see that I have 2 terms. They're not perfect cubes, but they are perfect squares. And we also have a difference. So this is a difference of squares kind of in disguise. So remember, with difference of squares, we also need a and b. So in this case, a is the square root of that first term. So what I would multiply times itself to get x to the 4th is x squared. And b, I need to know what times itself gives me 16, and that's 4. So remember, my difference of squares formula is a minus b, a plus b. So the tricky part here is that we're not finished, because look at the 2 terms. The first one is x squared minus 4. That is still a difference of squares. So I can still factor that x squared minus 4. This time, a is going to be x, and b is going to be 2. So it's x minus 2, x plus 2. And then we still have our x squared plus 4. So remember, there is no factorization for the sum of squares. So there's nothing more I can do with x squared plus 4. So this is my factorization. All right, this last one is something that's also going to come up. We've looked at something similar to this already. If we didn't have that minus 8 on the end, we've kind of looked at what we could do if they had a common binomial factor before, but now I actually have 3 terms and one of them doesn't have that binomial factor. So for this, we're actually going to substitute a different variable for that common binomial. And it's just kind of a practice that we normally do in math, that when we substitute, we call this a U substitution. So I'm going to let the variable U equal to that common binomial term a plus 3. And the reason that I'm going to do that is so I can rewrite this as something that looks simpler to factor. So if U is equal to a plus 3, I can write that first term as U squared. The second term would be minus 2a, and then bring down the minus 8. And you see now the trinomial that I need to factor looks a whole lot simpler. That's, I don't have a GCF other than 1. My a is equal to 1. So I can determine that c is negative 8. I can list those factors. And then we determine which set will give me b equals to negative 2. And that's going to be the 2 plus negative 4. So this is the one where we can just use the factors. So if I have u squared minus 2u, y'all be careful and don't let me do stuff like that. That was supposed to be a u. Go back and change that in your notes. That's u squared minus 2u minus 8, sorry. So we've got u squared minus 2u minus 8. To write that as the 2 binomials, we just determined that the factors are positive 2 and negative 4. So if you multiply u plus 2 times u minus 4, you will get the u squared minus 2u minus 8 back, but that's not the original problem. So we're not finished. Now we have to go back and undo the substitution that we made. So now that we know how to factor it, we have to go back, and everywhere there is a u, we have to put back the a plus 3. So a plus 3 plus 2, and then a plus 3 minus 4. And you notice we have some like terms. The 3 plus 2 is 5, and the 3 minus 4 is negative 1. So this is my final factorization.